All right, I feel good about this. All right, I guess we'll get started then. So today we're talking about development operations, which may or may not mean anything to you. How many people have heard of development operations? 1, 2, 4, 9, 11. Okay, that's a made-up number. So a year ago, I actually made this slide deck, and a year ago, it was like one person in the entire crowd of 40 or 50 people. So development operations has actually kind of started making headway as far as people recognizing what it is, and we'll get into all that. But one thing interesting to a lot of you probably, if you're in the InfoSec community, is if you're paying attention on all the Twitter stuff going on, a lot of InfoSec people have started kind of espousing development operations stuff lately. And I think it's going to pick up more and more. There was actually a Gartner report out 2 months ago that talked about DevOps sec, because it wasn't short enough to say DevOps. They actually threw the security part into it. And so there's kind of some things going on with the security community and wrapping it into the DevOps. So if you're on the sysadmin side, networking side, development side, or security side, you'll probably be able to take something away from this conversation that we're going to have about what that is, how it looks, and what that might mean to your environment or company. Most slide decks I do don't have really any rhyme or reason why I have a picture in there, because they're just like, oh, it's a cute photo, or it's interesting, or it's funny. This one actually I looked for specifically and picked this one. So a barn raising, if you think about it, is this really community-oriented thing, right? It's all these people that have maybe disparate ideas about religion or about families or about some sort of organizational matter. But at the end of the day, everyone has a purpose of, we need a barn. We need a place to put stuff. We need a way to do certain things. And we need people that we can rely on to get this project completed. So if you look at this picture and you see all these people that have probably a ton of conflicts between them for other reasons, they have this common goal, which is, let's raise this barn, get it up, do it for the community, and move on. Development operations, in my opinion, will kind of cover why that is. Has a lot of commonality between this photo, because whether you're a developer or you're a sysadmin or you're a network ops guy, at the end of the day, it really is supposed to be a team effort, right? It's supposed to be breaking down barriers. It's supposed to be about working cross-cubicle areas. And it's about the common goal of, let's make an architecture or an application that stands up to what we need for a client base or for our company. So just kind of keep that in the back of your mind as you go through this with me. Let me just get some of this up here. So whatever a senior consultant means, that's what I am now. I do security, I do operations, I do everything from writing statements of work to doing web application security tests to writing code. I kind of see the gamut now. My background has primarily been in Linux systems administration, web programming, kind of a broad range, which for me is why DevOps makes sense, because I've been on both sides of the coin. I've seen what it's like for a developer to want to roll code, and operations say, well, we can't roll code. The SDLC clearly says we can't roll code right now. And then the operations guy who says, well, we need a bug fix that you guys should do because our WAF doesn't protect against the SQL injection. And the developers are like, well, we'd like to, but that's going to break some functionality, and we really don't want to do parameterized SQL queries. So sorry, it's just not going to happen. And there's a lot of animosity between different sects of IT in general, but especially when you talk about the Web 2.0, web application, web software as a service, that whole thing, there's a lot more going on there, because a lot of companies now are based around this idea that a website is our company. It used to be a website was just like window dressing on top of what the company does. Now it's the company is a website. Not a one-to-one correlation, obviously, because it's mobile, but you look at Instagram, billion-dollar acquisition from Facebook, was it 515 days that they were a company? And you have to be prepared for that on the operations side, but you have to be prepared for that on the development side as well. You have to scale in tandem, right? So that's me, and we'll get into some of the experiences and whatnot, but every talk, whether or not you want to believe it, someone probably quotes Wikipedia, so I just call it out. We're quoting Wikipedia, because it's a good place to start. So DevOps to Wikipedia as of a year ago or so, processes, methods, systems communication, collaboration, and basically it spans that whole development cycle from the initial you write code to you test it to you deploy it. That's kind of in a nutshell what DevOps is. It combines the two words, it combines two methodologies. But that really doesn't give a super complete picture of what we're talking about. The community is always probably the best place to go, especially the people who are kind of like the patriarchs of community in general around DevOps. Stephen Nelson Smith, Damon Edwards, James Turnbull, they all have their claim to fame on why DevOps is something that they kind of architected, why methodologies that they've implemented, or even a blog post that they wrote had this kind of framing situation on what DevOps is. I won't read all these top to bottom, but kind of the bigger overarching picture here is that if you take development and you take operations and you streamline how the interactions happen, you have the potential to have not only a more efficient enterprise, but one that has less bugs, less headaches, less deployment rollbacks, all the kinds of things that if you're a developer, the last thing you want is to roll code to production and the sysadmin go, well, your code sucks. It breaks on. You should have known that we were running MySQL 5.1, and MySQL 5.1 doesn't support that feature. And it's just, there's such a breakdown between people. And I worked at a company called ePrize. ePrize in Detroit, big digital promotions company, top 100 brands in the world, Coca-Cola, all those great names, right? It was interesting as a sysadmin to see the thorough work they did on the development side to get really basic code off someone's laptop all the way to production, past the client, past QA, and then into production. And until you work in a software engineering environment, you really can't understand what that looks like because it's such a ingrained process in people that care about software engineering. And I think the biggest thing in IT that we lose is that, or maybe to reverse it, there's so much apathy in IT in general. We have people that they really just want to, whether it's just restart an Apache service, or they want to, put a database online, or put a name server online. At the end of the day, they're not worried about the common goal of the company. They're not worried about the common goal of, if I don't do this, the developer looks bad. If I do this, the developer looks like he's awesome at his job. And we lose focus because we're not thinking of the people across the cubicle walls. We're not thinking about people across in Europe that's doing some of our QA work, right? And these kinds of ideas that these guys have up here are, they want to make things better. They want them to be more than functional. They want them to be awesome. They want to care about the company and the teams they work with, even if it's not their team. So John Willis, it's funny because John is an awesome guy. If you ever had a chance to see him speak, he does a great job. Since I made the slide deck, he's changed jobs 3 times. So every time, the only thing I update in this entire deck is his fucking company. So he's at Enstratus. He was at DTO Solutions before that. He was at Opscode, who makes Chef, which is a configuration management platform, before that. So every time I'm like, John, you're ruining my day because I have to update this thing that I thought was done. A very important part that he really instilled for me, and the reason why John is a good person to quote is because a lot of this whole DevOps, as far as a name to associate with a bigger idea, happened in Ghent. Is that the proper way to pronounce it? In Belgium. And it was basically called DevOps Day. And this really awesome guy, Patrick Dubois, came up with this event, and it was kind of after this other community-related conference. And what came out of that was sort of the groundwork about DevOps as a movement rather than just, we see something here that kind of makes sense to us, but what that really looks like in actuality, we're kind of hashing out. And to be fair, 3 or 4 years later, we're still hashing out what that means, but it matters enough that people care to hash it out, that we're making progress. So culture is important because beyond a tool you can use, far from that one software you're going to download off GitHub or SourceForge, if the culture of the company is we're ingrained, we're buckled down, we know what we're doing, we're good, you're never going to have real progress in a company. And DevOps really gets behind the idea that no matter how well you're doing, no matter if you get a $1 billion acquisition or not, there's always something you can improve upon, either at a technical level or a team level. And teams are always kind of the lackluster point, in my opinion, from the jobs I've had. Sometimes you have 1 or 2 good guys, and you have 3 or 4 anchors that pull your team down because they just don't give a shit about making things better. And in DevOps, the whole idea is let's wrap our eyes and arms around this idea of we have all the power, we have all the technology in the world, why aren't we using it in a way that's actually transformative for this company? So That's not DevOps culture. You know, all the stock art in the world is not going to change that. The hackers, you know, are not DevOps culture. It's not about. It's definitely not that. It's not about how you look, the way you act, the clothes you wear, the style, right? I know IT and especially the hacker community can get really abstracted, and we start thinking of like opinions on people based on their almost hacker etiquette. We don't give a shit about that in DevOps. What we care about is that as a culture, it's focused on real growth of a team for common goals that are going to push something beyond what you could have pushed prior without DevOps. So DevOps culture, if you think about all the things you do in a daily kind of operations or development side, if you're kind of set towards DevOps, it's about the efficacy of your team, your infrastructure. It's about working with people, whether they're right next to you or they're across in Europe as some like little QA branch that you guys think are just, you know, contractors for hire that have cheap wages. It doesn't matter. The operations development push-pull, if anyone's ever worked in either side of that, you know that that's true. You know that there's always some reason why operations can't do something, and you always know there's some reason why development won't do something. And then at the very kind of culminating aspect of this, if you really treat your job as a job, it's not a career, it's not a profession, you're going to be the checklist guy. You know, it was funny, we were at a presentation earlier for, you know, QSA versus hacker, that whole thing with secure state, awesome presentation. And that's what it comes down to. The PCI compliance thing is a great example, analogy for, yes, you can do the minimum that's required of you. Or you can take this as a guideline for what you can do better than you are doing now, and then improve upon that. And it's all your perspective on things, right? You know, there's a lot of things in IT that we just gloss over because it's easy, and the DevOps mentality kind of says, we can do that, but why would we do that? Why would we do things worse than we could do that? And, you know, so it's a lot of, you know, to some people just, it's a psychological thing. Maybe it's hippie bullshit. I don't care. At the end of the day, it gets results, and that's kind of what I'm bringing to the table. So 2 examples. These are pretty much not verbatim to what I've had to do in operations or development, but it's pretty close. So the first one is just a quick dialogue. So the developers, Ruby has a release. Maybe it adds some functionality. Maybe it fixed the mass assignment vulnerability that GitHub got burned by, whatever. At the end of the day, they want something rolled out, and they want to test it because, you know, they want to do things right. Operations, we're not capable of taking an entire production environment, copying it out to testing, and having one-to-one parity and saying, yeah, go to town. Once you're done with that, we'll roll it to production, and we have full confidence this is going to work. The second one is more funny. So you have some obscene amount of servers, bunches of data centers, lots of, you know, BGP appearing between all this stuff, and this crazy-ass developer wants you to delete a single file off servers that have this like really marginal difference between all these other servers. And the reality is this stuff happens. You might not like that it happens. You might not want to be the guy that asks for it or do it, but this kind of really almost niche operations or development stuff happens all the time. So we'll revisit that in kind of Redux after we've seen the scope of what DevOps might be able to do for us. Agile, anyone, developers in here do Agile as kind of no? Okay. Yeah, one person. Yay. So what Agile gives to us, let me get all these up here. Oops. Just kidding, going back one slide. So what Agile gives to us, again, it's kind of like this just methodologies, right? I mean, there are like physical things that you do differently when you're doing Agile, but you know, simple concepts like maybe you do stand-up every morning, right? You talk about what you did yesterday, talk what you're going to do today, maybe talk about what you're going to do tomorrow. You set the pace for the week, you set the pace for the day, and you have expectations. Pretty straightforward. Seems reasonable, right? And the interesting thing is, at ePrize, we actually did stand-up in similar Agile mentality for operations. We stood up there with the developers, and we said, here's where we are with implementing Kerberos in this implementation, or here's our LDAP deployment in Tomcat. This affects developers, whether or not you want to admit to it, and to not stand up with your team, even if you don't think of them as a team, is silly because we're missing out where each other are in a process. Working software is delivered frequently. There's a lot of companies like Etsy that roll releases like every half hour because they're insane. John Allspaw is an awesome guy if you read any of his books. There's a certain kind of pace to it. If things change in operations or development, you can adapt to it. There's some flexibility built in. Even something as simple as an IDE, right? There's a consistent environment you're working in. You guys know how to do syntax highlighting, just really simple stuff that sometimes operations just don't latch onto about those kinds of simple ideas about how to keep consistency between what they're doing versus another sysadmin. So good, bad, right? That's obvious. What I hate though is when IT is really good at generalizing, right? It's very easy to say this is bad, this is good. But why, right? Are we missing out on the bigger picture here? So better physical infrastructure allows you can replace the system quickly. If there's a patch cable, you can actually find it in there, right? And you're not going to knock another one out. If you're walking by a rack and there's a amber light, you might look at that, right? You can't see that kind of stuff in the cluster that was shown versus the nice racks. One that is often missed, and I think a lot of the problem with why people leave maybe companies like in Michigan, for example, where I'm at. You can go to San Francisco, and people there just seem to have a better grasp of technology. They seem to have a better appreciation for it. And if you can choose between working in Detroit and you're this awesome network engineer, this awesome operations guy, are you going to go to the company who has racks that are messes, that are rat's nest of cables that you're never going to be able to deal with? Or are you going to go to the company that has well thought out cages, they have doors that are actually locked, they have structure to the racks? Well, if you have the talent and you can pick between the two, which isn't always the case, you're probably going to pick the company that has the nicer racks, not because you're like, oh, well, yeah, that'll be easier. You're thinking that this company cares. You're thinking that if I come in here, it's not going to be my job to change an entire culture. They already have the culture. I'm going to supplement that culture, and we're going to make it better together. Taking pride in your work is something that's definitely overlooked, I think, in IT a lot of times. Old operations. Anyone in here a sysadmin by trade? Okay, cool. So old operations, some of these are going to be funny, some of these are going to be antiquated, depends on where your company's at. Automation is bash scripts that you've written, hard-coded values, maybe a variable, God forbid, and that's your automated deployment mechanism. SSH for loops is like the living standard of a company that doesn't have configuration management. For I in, tick cat out some serverless file of all your hard-coded IPs, run a command on each server to upgrade, some packaging with Yum or something. Tarbles are configuration management. You tar up Etsy, you've got a configuration management system, right? Diffs, right? Diff UNR, you don't need anything more or less than that ever to figure out what's different between files. The monitoring is a big sticking point, and maybe just orders of magnitude. If you are monitoring hundreds of servers and you've ever had to configure Nagios from Vim and actually edit one server at a time, add them to groups manually, add service checks manually, and then go, oh shit, I should have tweaked that one for this disk usage versus that memory usage. You know the pain points that are there, and you waste more time making sure that you didn't screw up your Nagios config running Nagios, -v on your Nagios.conf than you do actually doing work. This is called, depending on who you talk to, the last part there, the fifth story test or the fifth story, whatever. If the server dies or it falls off the roof, everything's going to fall apart. Or, and more commonly, I think in my opinion, if that administrator leaves or he falls off the roof, everything's going to fall apart. A lot of operations, whether you're a developer, you're a Linux admin, or you're a Windows admin, there's always kind of that guy that if he leaves, nothing's documented. Nothing makes sense. Everything's a shoestring. Everything's like a cron job that runs as his user, that SSHs with a public key auth that goes to his account on another server, and it's passworded, and so you don't have that. It's just a mess. So that happens all the time, right? That's operations, real world, most places. This isn't a political slide. It just made sense. So we know that all of these things are not great. We know that there's a lot of things we can do better, and there's a lot of people in here or elsewhere that want to do better. Configuration management, we'll talk about all these really quickly. Configuration management, task automation, the SSH for loop is not the way to do it. There's no structure to that. There's no error code response mechanism that's built in to give you a valid response that you can trust in. Reverting bad infrastructure. Have you ever made like a massive commit to some infrastructure project, rolled it out, and then be like, oh shit, and then you start like, yum, uninstall, yum, it's just not sustainable, right? Even to the point where we're going to talk about IDEs and behavior-driven development. If you're a developer, you guys know what those are. If you're operations, you might not, but that's no excuse because you'll see in a bit, you should. Totally off. Okay, so Puppet, configuration management is this overarching topic, right? Puppet, Chef, BCFG2, CF Engine 3, there's all these awesome options, okay? It's like Linux distros. I don't care if you use Debian, I don't care if you use Red Hat, whatever. You're going to pick one eventually, right? You're going to stick by it, you're going to learn it as well as you can. In this case, here's an example of infrastructure as code. So you have your resolve.conf, you have your OpenSSH service that you want installed, you have your name service that you want to make sure that if it's ever stopped, it restarts itself. You don't have to log in to restart the service. That makes sense. Even something as simple as temp. How often do you go on a system and be like, shit, temp's full again, fuck. All right, cron job script, let's make it, if find equals this many, or dush equals this number of bytes or this gig, let's purge temp just in case before we run out of space. All these kind of hacky things happen all the time, but the reality is you can automate that in a way because you can write code that you can apply to a Linux system, a Solaris system, a FreeBSD system, and it'll abstract it, just like we abstract databases. So if you're running MS SQL, MySQL, Postgre, whatever, most people these days don't write code for MySQL. You write code for a database abstraction library, which takes care of all the nasty bits of each SQL implementation. We can do the same thing as infrastructure as code, where it abstracts you from the ugly stuff, and it installs things and manages things and sets permissions the way you want across any system. Even Windows now with Puppet has file support, MSI installation support, all kinds of cool things. So mCollective, I mentioned that the SSH for loop is not really a panacea for automation, for multiple task management. Marionette Collective, Funk, Fabric, all these cool different software applications, they do it in such a way that there's actually logic behind it, God forbid. So it's an RPC-based framework in the case of mCollective. You can write plugins, you can put them client-side, you can call client-side, you can expect certain response error codes. If something fails, you actually know it failed. You don't have to regex things to figure out it failed. Having a queue system is a huge deal. Rather than doing real-time SSH for loops that if it fails, you don't have to put a sleep value in to retry it and all this crazy stuff, you pop it on a queue, right? The subscriber to the queue, which is the client system, pulls it off the queue, runs the job, spits it back onto the queue, gives it back to the server system, if you will. And that way you can actually aggregate thousands of systems, passing back data through a really simplified but also efficient mechanism to aggregate this data out in a way that we understand as developers or sysadmins. If you take something like Puppet or even Chef, they have a really deep concept of metadata. When we start talking about, is it a Linux box or a FreeBSD box? Is it a Red Hat box or a Debian box? A lot of things matter. You take something as basic as the Apache 2 package on an app system, we'll just glorify and say. On an app system is the Apache web server. On CentOS, RHEL, it's HTTPD, right? So if we have metadata that we can say, if this, then this, we can have one configuration management manifest, we'll just kind of genericize, that will install whether or not it's on Ubuntu, Debian, Red Hat, or Cent. Because it knows what OS it's working with. It knows what IP, it knows if it's virtualized instance, it knows if it's an EC2, it knows all these things that you as a sysadmin always have to think of. Okay, well, it's on this infrastructure, it's virtualized, it's x86 64 versus i386 or 686. Those things always make a difference when you guys are writing scripts, right? It makes a difference when you're doing stuff as a manual sysadmin. We can do the same thing, but automate it in such a way that you don't have to think about it. It deploys the code, interprets all the variables, and then rolls stuff out as needed. In this case, just a quick example, purpose is basically a metadata variable for anti-spam, antivirus. That's what the ASAV means. We check the status on the spam assassin. I've redacted some of those things. But we see that all 5 versions are the exact same version. Have you ever thought, man, I wish I knew what version everything was at for a certain package across 1,000 servers? This comes back in seconds, not hours, you're not running a shell script ad hoc. This comes back to you right away. And it applies for any package, any whatever. Portability environment. I do a lot of talks about cloud computing, especially EC2. That's kind of my wheelhouse as far as cloud stuff goes. And the marketing, whether it's a real cloud provider that actually has basic ideals related to NIST's idea of what cloud computing is, or some other Cloud Security Alliance's ideas of what cloud is. There's a lot of companies that say, well, we've installed VMware, and we'll start a virtual machine for you. We are the cloud, and that's not true. There's a lot of tenants, on-demand self-service, broad network access, all these things that NIST have defined, and most people are reasonably comfortable with at this point. The thing about cloud, though, and the thing I always really emphasize, no matter whether it's security related or just deployment related, there's this ideal about cloud computing, and then there's a reality. And especially at an infrastructure as a service level, which is what a lot of us deal with if we're talking about EC2, or we're talking about, soon enough, Windows Azure will have a full public infrastructure as a service where you can start up a full instance of Windows and control it if you're not already in the private beta. Even things like Linode, right? There's a lot of environments, and we look at things, and people get really scared about vendor lock-in. The thing about infrastructure as a service, if you are fearing vendor lock-in, I can guarantee you've already done something wrong. If you can't take your environment and roll it out to VMware ESXi, if you can't roll it out to Rackspace, if you can't roll it out to EC2, and you don't give a shit which one it is, you're doing it wrong. And the reason why is because portability of environments is your job, not the cloud vendor's job. They're giving you an OS installed in a VM and saying, have at it. If you say, well, Amazon locked me in because I made an AMI and it's all hard-coded data and I can't get that out possibly and it's going to be a pain in the ass, that's probably because you didn't think about, oh, I should leave at some point probably, or I might want to use 2 vendors, not 1 vendor. Because what if Amazon has another EBS failure? What if Azure has another, we can't calculate what the date of leap years are? And those all happen. So when we're looking at portability environments, remember that not old, seconds ago, topic about, the developers want a new Ruby environment, and they want it to be exactly the same as production. Portability environments. You want a new staging? We can copy what we have. We can roll it out with configuration management, give it to the environment in whatever choosing you have, and you can test what you want to do. Simple things like just treating all infrastructure, not just cloud infrastructure, as it's going to go away. The funniest part to me as an operations guy at heart is when people say, well, the cloud, you're not supposed to trust it. You should never trust any system. Why are you trusting anything in IT? Systems break, whether it's in the cloud or it's at your data center, systems go down. If you have a single point of failure, it doesn't matter if it's in the cloud or a data center, you have a single point of failure, right? And configuration management allows us to say, okay, well, our data center, Equinix blows up. All Equinix data centers blow up all at once. That would be horrible. But why are you stuck at Equinix other than maybe your IP allocation, right? Change your host names, point it at Amazon, run Puppet, deploy your systems, and you're back up. If you can't do that, it's your fault, not theirs, not anyone else's. So my quote, you guys can quote me on this because it's happening right now. The cloud means nothing unless you can quickly deploy, configure, maintain, destroy hosts without intervention. If that's not true for your infrastructure as a service, you haven't thought out what you're doing in the cloud. And you're probably losing money too. That's a lot of people go, hey, the cloud ROI, we're gonna really rock that thing. We're gonna, all this operation cost is gonna offset our CapEx and all these other cool things. It can be true for certain things, it can be true. However, if you're not doing some of these things well, you're probably not actually making money off of it or saving money, as it were. Infrastructure as code. What's interesting about that, if you guys saw the previous slide, it's just text, right? It's text that defines what a system should look like. The other term you guys are going to hear a lot is called desired state. So a Puppet configuration management system is looking for desired state. If a certain file has permissions of 600, Puppet says, oh, it should be 644. When Puppet runs, it's going to say, oh, gotta chmod that and make it 644. if we look at code in general, why aren't we doing the same things with our infrastructure as we are with our actual code? So all these awesome developers are doing Agile, they're doing certain best practices for development, and operations people are lagging behind. Accountability. Other than change management systems directly, when was the last time you were able to say, okay, who made that change, other than like reviewing bash history logs, right? What if you committed your infrastructure change to GitHub, and then Puppet rolled out your GitHub commits? Wouldn't that allow you to understand what actually happened and who did it and when they did it, rather than kind of guessing or hoping that the bash history log didn't get truncated? Revisions. If you have a situation where something broke and you maybe edited a Apache file and, man, there were like 100 line edits in there and things just went really poorly, vhost broke and everything hit the fan, why can't you just say, git revert and it works on infrastructure? Differentials. Why can't you do, just a git diff on something for infrastructure and say, oh, I see there, Mark changed it to, Chmod, whatever. That made it read-only, and read-only didn't show up in Apache, and hey, we understand what happened. Environments, let's try staging, let's try test, review, production. Move it up the chain just like a normal repository does in code. Branches, if you've had a couple drinks, the big thing that I always was a proponent of, I'm going to branch my code base and commit all my changes to a drunken code base. And then tomorrow I'm going to review those and merge them back. You can do the same thing if you really want to with your infrastructure now. And history, which is, these days, honestly, I'm more into operations as far as business operations, keeping things running, change management, ITIL, all those cool things that really make a business function as it should. And what's so wrong with operations having the same kind of legacy behind them as developers do? Why can't we say this is what we did this year? Why can't we look at all the commits we've had and show this is what we've actually accomplished? The most exciting thing I've ever gotten out of kind of the DevOps mindset and just infrastructure as code in general, developers can submit pull requests. If you guys are GitHubs or Mercurial or whatever, developers can submit pull requests for infrastructure. They can say, I want to upgrade Rails whatever to Rails whatever. I can upgrade Ruby version blah to blah. And you can see it, you can comment, annotate it, you can, whatever, change the commit, and you can roll a developer's request for production hardware, essentially, to your environment the same way they treat code. You've completely eradicated all barriers between you and operations, because developers know what GitHub is, they know what version control systems are, and they know how to edit text. They are now essentially in command of an operations with full review, full parity between the two teams. And that's a really, really impactful thing when you're talking about efficiency. We talked about IDEs earlier. There is an IDE, which is basically a plugin for Eclipse, more or less, that lets you edit infrastructure as code the same way your developers are editing their Java, they're editing their PHP, they're editing whatever. We can understand them and they can understand us because we're editing things in the exact same way with the exact same application. Behavior-driven development, testing. BDD is more kind of if anyone follows DHH, who kind of, really, he's the guy behind Rails, essentially, 37 signals. He's a crazy guy to begin with, but I really enjoy a lot of what he said. And he had this whole blog post recently about, well, if they're doing BDD, please tell them to go get me some pixie dust from Fairyland and sprinkle it on all my stuff. Only because you basically talk in English, you speak in English essentially, and that renders down to tests. So he's kind of a hard-nosed as far as testing goes. But we can actually do behavior-driven development against infrastructure, okay? Monitoring, another huge thing. If you've ever deployed 1,100 or 1,200 or 1,500 service checks on Nagios, and you deployed it across 200 hosts and 500 groups and whatever other numbers you can come up with, imagine never doing that again, never editing a single line of Nagios or Xenos or any other monitoring system you have, because the architecture, the Puppet management, the Chef, whatever, it's actually dictating, we have an Apache host, we have metadata that says it runs 80 and 443, we have metadata that says 80 should return to 200, 443 should return to 403 by default. We have metadata that states that this specific host should have graphs for ETH0, ETH1, and ETH2. This other one should have metadata for ETH0. And while it sounds like, oh yeah, it's a theory, that's cool. If you check out my GitHub at the end, I actually have code up there that will interrogate services, whether or not they're check configured on or the relevant Debian equivalent for Upstart or whatever. If it's on, it'll actually add a check automatically. So if you have a system that's running at 2 a.m., someone is doing like really late night maintenance work, they enable Apache as a production service, it's going to catch that and actually add a service check for Apache without you ever touching code. You're never going to touch configuration management in terms of Nagios ever again, because you're deploying infrastructure as code that actually understands what monitoring looks like. Puppet specifically actually has built-in Nagios infrastructure as code bits that you can say host, service, whatever, and it'll actually write Nagios config for you. Same thing for Munin. It'll write Munin code for you, or Cacti or whatever you're so inclined with. And at the end of the day, you can deploy an entire environment with every single check you want, with metadata filling in passwords and usernames and all the little criteria that goes check to check, and it'll be all automated if you do it right. So there's some what I call DevOpsy stuff, and these projects are really different stages, in development. Foreman has really come a long way since I actually put this in here. Foreman is kind of a, if you think of the cycle of system deployment as we need to create a system, we need to initialize some kind of basic configuration, and we need to deploy configuration management to make it a certain system. Foreman does that top to bottom, not only with physical boxes with Pixie boots, it'll do KVM, I think it'll do Zen these days. And you can basically say, I want a XVM, all through a web interface, an XVM with this Puppet configuration module to be a bind server. Click a couple buttons, and now you have a bind server online configured with zone files attached. Rundeck is kind of akin to mcollective, similar idea. It has a little bit more interesting aspects as far as authentication integrations. It functions over SSH, whereas your mcollective deployment is probably going to be functioning over a queue with hopefully SSL between everything. And so different deployment, but another good option. Vagrant, and I'll actually add to the list something called Veewee, V-E-E-W-E-E, I think. So Vagrant essentially automates your deployments of VMs in a way with VirtualBox, and I think they're adding support for VMware Fusion at least, that combined with Veewee, which is essentially template-based VM creation, you can say, I want a Gen 2 i686 VM with X megs of RAM, X cores, edit a couple lines in basically a kickstart file or a definition file, run a command, walk away, you come back, and Puppet's installed, Ruby's installed, all your gems are installed, and to the point where Chef and Puppet are integrated, that you can actually edit this Vagrant file and say what modules you want to run. So think of all the times you do a quick deployment with something, and you want to see if it works, right? That's super common in testing environments. You want to see if it works. I know there's people in here, because I'm one of them, that used to build a Debian system, run some code, hope it worked, and then rebuild a Debian system from scratch if it didn't work. Now, obviously, VMs, you can snapshot, you can do all that kind of cool stuff. But what Vagrant allows, it actually allows full automation from, it'll actually create a DHCP server, it'll create a Pixie server, it'll let you specify an ISO, it'll download the ISO if you don't have it already based on if there's MDF5, some mismatch or whatever. It'll let you configure VM credentials as far as how you authenticate to the VM itself. All that's automated. And as far as Veewee goes, there's 30-some templates, Windows 2008 server, Linux, FreeBSD, whatever. You can create a VM, have it fully staged, have it on DHCP, have it all configured, and you've only basically copied and pasted a line from an output on Ruby. If you're trying to do development and you're trying to do multi-environment development, this is going to make your life amazing. Cute dog slide. So the ability to be agile is kind of this bigger overarching idea in DevOps. Agile is not necessarily DevOps. DevOps isn't agile, but there's a strong correlation. The idea that if you have an environment, you want to replicate it, you want to test it, you want to you hate your current provider, you want to move it, you should be able to do that. Infrastructure, if you have to revert things by having one horrible bash script that may or may not work, and another one to revert it in another horrible untested bash script to revert, you might want to start looking at kind of like broader ideas about how people do development, because the development community, obviously, for X number of years, has had their shit together pretty well, right? I mean, development is relative to operations 5 or 10 years ahead, because they understand structure. They understand that when people deploy something, they want it to work. In operations, a lot of time we go, shit, well, here we go. And that's not acceptable at the end of the day. The other thing I'll say about operations, and not to black hole my guys anymore, but in operations, you can blame anything on anyone. You can say, oh, shit, ISP went down. You can say, oh, there was a bug in Apache. You can say that, oh, the developer didn't know that we didn't support that version of MySQL. And it's very easy. It's a very authoritative position because you know all the end roads to failure, and you can kind of manipulate them as needed. It's not a sustainable way to live, right? Parallelization in general with commands, if you do an SSH for loop, it's not going to be concurrent. There's not going to be 5 threads running, right? It's just going to be, oh, one after another, hope this works. You can do things with mcollective across 1,000 hosts, and in a matter of seconds, you have results from all 1,000 hosts at one time, and you aggregate them, you summarize them, you can build reports from them. Develop tests against your infrastructure. Deploy monitoring is one of my favorites, obviously. So here's the Redux. So the first one is, again, we have a development environment we'd like to have staged. It has Ruby. We need a new version of Ruby. EC2, Rackspace Cloud, Linode, Vagrant. What do you want it in? Where do you want it? How do you want it? We can roll that out for you in no time flat. No big deal. The second one, and so it's very cocky to be like, well, how about the next 3 minutes? It's this horrible thing that we could never do before, and it's just unreasonable for anyone to ask us to do in 30 minutes. We're now saying, let's do it in 30 or 3 minutes. That is not fake. It's not manufactured. That is real, actual. That's all you have to do with mcollective to actually do that. So it's one of those things that a little bit of planning goes a long way. And as far as technology goes, there's a million applications we all use. There's a lot of cool things. You can always pick 100 different ways to do something. At the end of the day, we're all picking the one that we feel comfortable with that's going to get the job accomplished so no one's yelling at us. mcollective and some of these other, Fabric and Funk and all these other things, they allow us to do our job the way we want to do our job. We're no longer trusting that some routing issue happened midway through our SSH connection that we're going to break an entire cycle of deployment. There's a lot more assurances if you plan ahead to do things well. So whether or not you want to think of it this way, the buzzkill slide or the empowering slide, there definitely is a way to do this in every environment. The push and pull aspect to that is it's not going to be easy in most environments. The people that are your ingrained, we are the infrastructure, we are the developers, we are the whatever, people come and go, but we're always the statue in the middle of the room. Those are the people you really have to start kind of warping their mindset on what we do as an industry. Tools, practices, the tools are okay because honestly, a lot of times you can demo something and people are going to go, wow, that's cool, that's very impressive, you can do that now. The methodologies, the practices, that's the uproad. There's just people staring in front of you going, listen, we know you're new here, we know you want to do something cool, we know you want to make an impact, but just shut up. Just go over to your cube, do your work, and that's cool. It's going to be a really big challenge to make practices and methodologies actually happen. Planning, time, and money, I mean, those are the 3 things that stop anyone from doing anything in life, right? There's definitely a cost to buy-in, testing equipment or testing instances on EC2. If you want to do Puppet with an enterprise, there's a license fee. If you want to do hosted Chef with configuration management, there's a license fee. If you want support from mcollective, there's a license. There's always things you can do for free, or you can do it for pay. And whether or not your business is one of the companies that has a, hey, we got to use this money by the end of the year or it's going to go away, maybe that's okay. If you're a small company, if you're a small shop, you're going to probably use open source to the last little bit that you can get out of it, which is awesome. Every deployment I've ever done with Puppet, for universities, for managed services providers, for ePrize, big digital promotion companies making $5-6 million of revenue every year, we did everything open source. You don't have to get licensed. You don't have to do a lot of things. You know, the people that are kind of the grunt workers of IT know that at the end of the day, open source is kind of your bastion of hope. And you can do a lot of this stuff without ever even talking to a sales rep. So if that's your worry, don't stress about it. So overhead's always a concern. You know, one thing I really don't have up here, I guess, in a straightforward form is time, right? In operations, especially small team operations, time is usually the commodity, even sometimes more than money. You don't have, you know, Google has like 20% time or 10% time, right? Most operations people, they go home, they SSH back in, they start configuring something else, they do maintenance windows at 2 a.m., they, you know, all these enduring things that they have to do. This kind of interaction and this kind of, well, what's the point? It's a really hard battle to fight sometimes because it's hard to see the progress that could be had. The amount of time I saved by doing things with mCollective or configuration management or working with developers one-on-one in a way we both understand and can actually kind of have that mutual admiration for, well, we appreciate you did that for us, we'll do this, you know, make things better for you. It's just made the world of difference in operations for me. I've also been a developer, so I know the other side of the coin. I haven't experienced that as a developer, but I can only imagine what it's like to have that kind of real, like, you can relish the fact that, man, you know, we really got this accomplished, and we did it in a way that's sustainable, whether I leave or you leave or he leaves. And that's a, you know, it may not be something to everyone in IT, but it's something to me, and I think probably a lot of you have that same kind of feeling, like when you leave a company, it's actually supposed to be better. It's not just supposed to be get last paycheck and get the fuck out of there, right? You are supposed to leave a legacy that you can stand by. I have a buddy that works at U of M. He took my job as a Unix admin after I left. I've never heard one peep out of him for a complaint. And of all the things I've done in my career, that's probably my biggest accomplishment because I know he would have gave me shit the moment something broke. He would have not held back. He would have not told me like, oh yeah, everything's cool. He would have been like, dude, your AFS deployment sucked, your Samba deployment sucked, you know, blah, blah, blah. So there's so much crossover in our industry. There's so many of you guys that I've known for 9 years now. There's so many people that I've talked to before about DevOps or cloud or operations. And when we talk to each other, a lot of us get each other jobs. We work with each other at some point. We consult with each other. And every time you do something, I like to think that you're focused on, when my buddy comes in here, what's he going to say? How is he going to react to what I did here yesterday? And if you keep that kind of mentality, you kind of focus on some of these DevOps-y little, you know, ideas, your job's going to be cool. You're going to enjoy what you're doing. And then when you leave, you're going to be actually able to have a reference call rather than shit, pack your stuff, get out of here, tarball your files, and walk away. So there's my info, GitHub, website, all that stuff. So if you have any questions, I guess I'm going to go upstairs and chat for a while. Please hang out. And I love to talk about your environments, what you're doing as a company, or if you just have any questions about DevOps or any of these tools that I talked about. So thank you for your time.